Good morning, everybody. Hope everyone's doing okay. So today is March 19th. We're going to be talking about finding angles using trig inverse functions. Couple of things quick to go over just for all y'all that are my students. First off, Zoom office hours will be sent out today by Classroom and by Remind. That's going to be from 10 to 11 and 2 to 3. Some of you guys need to be stopping in to see me, I'm sure. If you have not seen the links, I've posted a few times, but Remind text messaging is available. You can email me if you need details about that, but please make sure you're checking that out, especially if you have lower internet access, if you can't be getting on all the time, or you just need a few extra reminders. And then lastly, the calculations assignment that was from Tuesday will be due at the end of today. So please make sure we're keeping up on that. I got about 50% turned in right now, so half of you guys need to be catching up on a few things. All right, so this should be a pretty short and sweet video. We are talking about trig inverse functions. That's where we're going to find the angle measure instead of trying to find the side. So we're going to keep using our three trig functions. That is the sine of theta, the cosine of theta, and of course tangent of theta. From the last few days and weeks, you should remember that theta is the angle I'm talking about. Whatever angle we're using in this situation, that's the angle of the conversation. That is theta. Sine is, of course, opposite over hypotenuse. Cosine, as always, is adjacent over hypotenuse. And tangent is opposite over adjacent. If you need a walkthrough of how to figure out where opposite, adjacent, hypotenuse are, and where theta is, please see yesterday's video. We'll talk about that briefly here in the next couple seconds, but if you need more information, check yesterday's video out. All right, so like we said, theta is always the angle we're talking about, and we've got a question mark here. We are trying to find what's the angle measure. So I'm going to throw my theta here, which lets me go ahead and label everything else. We'll change a little bit of color. So across from the right angle, as always, is my hypotenuse. The other side that makes up theta is going to be the side we call the adjacent, and then left over is the opposite. We want to use the trig function that you have information for, and in this case, I've got opposite and hypotenuse, so that means I'm going to use my sine function. Setting this up should be very straightforward, because we've got the sine of, well, I don't know this time, is going to equal my opposite, which is 47, over my hypotenuse, which is 52. Hopefully that makes sense where everything's going. We just plug stuff straight into this equation. To find the answer here, we're going to just use this new thing. It's called the inverse or the arc sine, which means that I'm just going to use sine with a little -1 up here in the exponent, and go 47 over 52, and that's going to equal my unknown angle, my theta. Now, you might be saying to yourself, Self, I don't know where to find all this. You guys do still have access to the Desmos calculator. Looking right down here, you've got the function button, which is the third over from the left, closest to the number pad. If we hit that, you'll see that you've got all three of those trig functions. We're going to be having a sine inverse, a cosine inverse, as well as a tangent inverse. So we'll bring up sine inverse, go back to main, bring up the fraction. I forgot what fraction I had, 47 over 52. And we'll just plug that in, 40. Make sure we're in the parentheses. Okay, if I mess it up, maybe you won't. 47 in the numerator, 52 in the denominator. Answer shows up right there. It is 64.66. We're generally going to round to the tenths place, which is 1 decimal over, meaning my unknown theta is 64.7 degrees. Remember, this does need to be labeled degrees because we are talking about an angle measure. We haven't been using feet or inches so much on the sides. A little bit less important there, but we are distinguishing an angle. I do want to see the degree marks put in correctly. The delta math will basically make sure that that happens. I'm sorry, I'll leave this up here In case any of you guys have the screenshots, I think I have this set up a little bit better, so I'll upload these notes to the Google Classrooms right after we're done. All right, so the second question, I'm going to run through 3 examples today. Second example, I've got my theta down here in the corner because that's my unknown angle. We're going to go ahead and label. I have my hypotenuse right over here. Making up theta is, as always, the adjacent, which leaves the opposite here. If I think back, we'll just go with the acronym SOHCAHTOA for some easy notes. If I look back to this, I've got the adjacent with a number, I've got the hypotenuse with the number, which means I'm going to use cosine. We'll set that up very simply because the cosine of theta is adjacent over hypotenuse. Don't need the opposite labeled here. Clear out a little bit of space. So I've still got the cosine. I'll go ahead and plug in the question mark. You can leave theta if you want to, and that's going to be adjacent over hypotenuse. And finishing it off, I've got the cosine inverse. So we're just using that little -1. That just means we do the opposite thing. Just think back, like addition and subtraction, those are inverse functions, multiplication and division. I don't know if people got a little bit lazier or what happened. We just call it the cosine and the cosine inverse. It just means you're finding the other bit of information that you normally plug in. So we'll have 9 over 10, and that's going to equal my unknown angle. Sorry about that. Once again, you can just go back to your Desmos calculator. Link is on Classroom, but it's just desmos.com. You can select the scientific calculator or go /scientific. Either way works. We'll hit function over here, and we'll go cosine inverse. I've got 9/10. Bring back to here. Fraction. Ooh. If you get a little mistake like that, no big deal. Just hit the undo button and make sure you're clicked into that parenthesis. Fraction. 9. I like the arrow on the keyboard a little bit more there. 9/10, and that's 25.84, which would just round to 25.8. All right, and one more quick example on this. I've got 29, I've got 17, I've got an unknown angle. Looking back at our little acronym, SOHCAHTOA. And labeling in theta as our unknown angle. We go through our hypotenuse. Hey, that's not labeled this time. I've got an opposite, and I've got an adjacent that makes up my theta. So looking at this, I'm sure you guys guessed just based upon the fact that we've used sine and cosine, we're going to do a tangent problem now. So tangent of theta, of course, is the opposite over the adjacent. So I just plug that stuff right in one more time. Tangent of theta is 17 over 29. And we bring that into the tangent inverse. 17 over 29, and that is my theta. Last but not least, that goes straight into our good old calculator, and that'll work out perfect. So we'll go here, tangent inverse, back to our fraction bar. I'm going to double check myself, 17 over 29. I'm working without a safety net. I don't have notes sitting next to me. 17 over 29, and that gives me 30.379. We're going to round that up to 30.4 degrees, and there's my theta. All right, so that's all we've got for trig today. You guys have the assignment up on Delta Math for finding angles. You also should have the quiz that's technically tomorrow. It's like 5 or 6 questions just over using the trig functions and the ratios, the stuff I've gone over with you on the 2 videos this week. I won't be posting anything tomorrow since it's just a quiz. If you have any questions, please see me during the office hours. I'll be holding those both today, which is Thursday, and tomorrow on Friday from 10 to 11 and from 2